as Sean said, I've got about 17 years in IT, all in all, 12 years desktop engineering, some failed VDI implementations, which I'll share with you and hang my head in shame, talk with you about some of my experiences at VMware, and then a little bit about what Pernix data is doing in this space. I was really excited about putting this session together because unlike my day job where I get to go out and talk to people about the products that we have, what I was asked to do here was really just share experiences and keep it very non-product focused. So it was a really exciting session to put together. I hope you guys enjoy it. I hope you keep it interactive, right? Ask questions, challenge me on things that don't make sense. Again, we're all IT professionals. We want to just make things better. So please ask questions as we go, and we'll kick it off. So going back just a little bit, when I was thinking through the content for the session, I thought about something somewhat similar. This was actually the first public presentation I had done for VMware when I joined. And again, coming from the customer side, I got recruited in to be an end-user computing specialist. And so you can see that the session was titled Over the Hump Without the Hype, Lessons Learned Deploying VMware View. And so from my VDM 2.0 days all the way up until View 4.5, this was the session title. And this was the very opening slide, Lessons Learned. And you'll notice the very first line item here, IOPS, right? So the lessons learned was IOPS. Well, what does that mean? Well, frankly, what it means is I didn't know what that meant. I didn't understand what an IOP was. I didn't understand the complexity of VMware virtualization as it went back to a shared storage environment. And so this is something that a lot of folks think about, right? If you go talk to any storage vendor out there today and say, I'm thinking about doing a VDI project, they're going to talk to you about a box that can supply some amount of IOPS. And IOPS are great. We absolutely need them. But what I want to talk about today is some of the challenges specifically around that. So yes, there are many other things to keep in mind for a VDI session. There's no way we can cover that all in a 40-minute VMUG. But I want to kind of focus in on this aspect of it as we go. So this is actually a Visio diagram from the first full-blown production VDI deployment that I did. We moved from a 16 guest implementation that got me a speaking slot at VMworld many moons ago, to a couple hundred seats here that eventually scaled to a couple of thousand. And as you'll see here, I've got some Dell blades connected back to some Dell EqualLogic storage. And once again, I'm going to call out the fact that I really didn't understand IOPS and the implications of IOPS when you're talking about doing things like booting hundreds of virtual machines or running an AV scan across a couple hundred virtual machines simultaneously. And so needless to say, this was not my best work by any means. It looks great on paper. It didn't run all that great. And so that's really what I want to talk with you guys about today. So this is actually a slide. I don't know if any of my ex-VMware folks are in the room, but this is a slide that I ran around with. I had developed it pre-VMware, and I used it every day right up until the day that I left, trying to help educate folks on the complexities of provisioning virtual machines and what they do to your backend storage. So the first process is pretty straightforward. Everybody's familiar with this concept, right? We have a template virtual machine, and we want 100 more, or some number more virtual machines. So it's a pretty simple concept, right? We simply clone that across, and to go through and figure out the math on that, it's pretty straightforward, right? We know how much capacity we're going to require, and as we scale that capacity out, we're going to add spindles, we're going to scale performance and capacity roughly with it. So that's fine. And when you add 100 virtual machines to your server workload, that's not that much SAN. But when you start talking about desktops, many folks are trying to scale to thousands of desktops, and this model simply isn't cost effective, right? You have to buy too much capacity. And so VMware came out with a technology called View Composer. Composer takes a single image, we create a snapshot. From that snapshot, we spin out a replica, which is basically just a copy with the snapshot applied. We lock this, we make it read-only. We create this hotspot on disk. We spin out a bunch of very thin, provisioned, if you will, small linked clones that all read from this replica. And the math suddenly looks so much better on paper, just like that Visio diagram, right? It looks really good. I've got all this capacity savings. I can run all these extra virtual machines on the same amount of capacity. The problem with this model, as I all too quickly found out is that when you look at that model in a slightly different angle, you can start to see what we're doing to the backend array, right? We've got all these virtual machines spread out across this nice scale-out model across our vSphere host. And what we're saying is that all those virtual machines are going to reach down across the storage area network, across a pair of disk controllers, to some hotspot on disk, wherever that replica lives, and all these virtual machines are going to read from that same section on disk. And so when you're talking about rebooting even just a few dozen virtual machines concurrently, imagine how much read I/O that puts on that particular replica disk. And so this sort of random I/O pattern, this problem that happens, is not unique to VDI, but it is very much exacerbated by a VDI workload because of the way our end users work. Server workloads, right? It's not uncommon to boot up a virtual machine server and never reboot it until some Microsoft patch makes us do it. But of course, a Windows desktop, right? It's not uncommon to reboot those on a daily basis. So I put this up here, well, because how often do you get to use the word chasm? This is actually a marketing slide, so I had to put it in just to be funny. But it actually illustrates a pretty interesting point. When we try to figure out this, how to architect storage for performance for our VDI workloads, you have a couple of different ways that you can look at the data. The first is that we can start at the VM level, right? We can go ask the Windows operating system, what are you seeing? What are you getting, right? What are the latency values? What are your disk queue lengths, etc.? And we can look at that. The problem is, once that I/O leaves the guest, hits the hypervisor, it disappears into this chasm of storage area network, which is a series of switches and disk queues and all sorts of things that we really don't have any visibility into. So we say, well, things aren't quite performing the way we want them to. We can't see anything from Windows. So let's go ask the storage guys, right? They must know. There's something storage isn't performing. So we go run our storage tools. By the way, anybody using more than one type of shared storage in your virtualization environment? Quite a few folks. The more storage tools we add, the more disparate disk arrays we add for specific projects like a VDI rollout, the more management tools we have to go and ask to try and figure these things out. Each one's going to be a little bit different, but every one of them is going to suffer from the same challenge, which is we can ask the storage what it's seeing, and in many cases what we see is it's fine. That del equal logic that I showed you at the beginning, right, on that Visio slide, it said it was fine. The storage guy said, you're crazy. Everything is great. I said, well, then why are my end users getting 10-minute logon times? Storage is fine, because the storage has a myopic view. It sees what's in its disks, it sees what's in its disk controllers. Anything that's queued up here, right, somewhere in the beyond, in this chasm of unknowing, it has no idea. And so the real challenge is trying to figure out what's actually happening between here and then figure out how to address the performance at that level. So this is the question, right? I can't tell you how many times in 5 years I've been asked the question. I get in, I do these workshops, I'd spend half-day lunch and learns with customers, and I'd start talking about the importance of storage and I/O and everything, and inevitably this is the question I get. How many IOPS do I need for VDI? Anybody have a guess? Enough. 32. 32. Yeah, close. It's funny, because all the numbers that are being thrown out, right, this is exactly what happens, right? And I used to be one of those, right? I was an industry expert. I had a number that you needed for VDI. Guess what I used to tell people that you needed for a Windows XP desktop? 10 IOPS, that's all you need. 25 for Windows 7 if you want to get crazy, right? Go talk to your storage vendors. Who said enough? Spot on, right? Well, how many you got? Well, that's probably enough, but I'll sell you this box that'll give you more. That'll be enough, right? And that's, unfortunately, that's the way storage vendors size VDI deployments these days. Well, what have you got today? It's fallen on its face? Yeah, we'll give you double that. That should be fine, right? That'll give you all the IOPS you need. And then there's this, there's always that guy that, forget about it, right? Just buy our appliance. Well, ours is good. You don't need to worry about IOPS. We've got a bajillion of them. And so I'm not trying to bash any of the storage vendors. we're not a storage vendor technology. We don't sell storage. We don't sell a single piece of hardware. So we absolutely need good quality storage on the back end. But trying to go out and size purely based on I/O is a real challenge. So how many do we need? Well, we'll come back to that. Let's talk for just a minute about the dynamic nature of IOPS. So as you can see, and I apologize, the colors here on the screen make it a little bit challenging to read, but this is a cluster of virtual machines running over a period of time. And as you can see, I've got a spike here of read I/O that's a little over 42,000 IOPS. And at that same point in time, I'm getting about 1,600 write IOPS. But you'll notice that over this relatively short amount of time, there's a tremendous amount of spikes. Read I/O, write I/O. This is very typical of a virtual desktop workload. We'll come back to that in just a moment, but I want to show you a little bit from my lab. So Sean mentioned my home lab, did some testing during the recruitment process to come on board with Pernix data. So I put this technology in my lab. I wanted to get a feel for what this actually did. And so I'm not really going to talk about the product per se, but I want to talk about some of the results as it relates to this sort of dynamic nature of IOPS. So here I've actually created a boot storm using 10 linked clone VMs. So Horizon View deployment, standard View 6 at the time. And I just ran a VB script that would go out and talk to 10 VMs, reboot them all simultaneously, right? Don't wait, just rip through and kick off the reboot on all of them. And the way I measured the complete time is not when I could actually see the Windows desktop again, but when View Manager actually told me that the desktop was available. Because there's a key difference, right? Rebooting, as anybody that's ever sat down at a Windows desktop, logged in and then waited for another 2 minutes while your profile loaded and things got ready and you could actually use it. When the services start and report into View Manager, that's when the desktop's actually usable. And so here you can see I rebooted these 10 VMs and I got a peak of 865 IOPS, which if we divide that out, that's roughly 86 IOPS per VM during that boot period. That's a lot more than 25, right? But what's really interesting is when we took the cap off, right? Using a little bit of technology, I removed the bottleneck, the constraint of the underlying disk, and I ran that test again. Notice now that I generated 2,462 IOPS, which is roughly 246 per VM, and also that the boot operation completed in half the amount of time. Now, there aren't too many physical spinning disks that are capable of delivering that much I/O. So it's an interesting trend. And by the way, I'm not the first to test this by any means. There are a lot of folks, I've read some great white papers on this concept that Windows will essentially take what you give it. I've seen folks generate hundreds and hundreds of IOPS with a Windows 7 boot when you give it unfettered access to really, really fast disk. So there's another interesting sort of component here. This is just kind of a side note. It's not specifically related to IOPS, but I want to talk for just a minute about the relationship between CPU and IOPS. They're much more tightly integrated than most folks realize, and it's something worth noting. So when you look at a typical PC, right, when the application wants to write something to disk, it has to use a CPU cycle to make that request. That request goes out, and we wait for an acknowledgement back. And if we don't get an acknowledgement back quickly enough, what do? Well, nobody answered, I'm going to call again. And so the application will use another CPU cycle, make another request, and this process will snowball if we can't get a response back in a timely fashion. And so what you're seeing here is actually, from my vCenter view, my overall CPU utilization during that first boot storm where things were not going so well. Right, not a tremendous amount of I/O. And notice that I never really got past about 80% CPU utilization, and for most of the time I was down in this 40 to 50% range. But when I took the cap off, you'll notice that I was actually able to much more efficiently utilize the CPU cycles of that vSphere host and burst and use almost 100% of the I/O, or excuse me, 100% of the CPU cycles for half the time. So we're able to actually get more work done all around for the entire virtual machine when we free up those disk cycles. Okay, but we're supposed to be talking about IOPS. So how many IOPS do we need for VDI? Well, Sorry, I can't answer it just yet, because one of the other aspects of an IOP is the block size of that IOP. And unfortunately, they're not all created equal. So taking a look at a workload here, as you can see, and maybe hard to read in the back here, but each of these different colored areas represents different block sizes. So I have less than 4K, 4 to 8K, 8 to 32, etc. Notice this big heavy pink area here in the middle. I think that's pink. I don't see that real well. Greater than 256K, right? Very large block. And if you're not familiar with large block IOPS, this is probably one of the most unknown, especially in the VMware space, not so much for a traditional storage guy, but this concept of large blocks being committed to disk, especially being written to disk, and even more specifically, writing large block to flash media can have a tremendous negative impact on performance. And so getting in and understanding the block sizes, whether it be from a cluster level and looking at it, the entire view of what's happening, or whether we get in and actually look at the individual blocks of how much is being read and written at a given time on a specific VM, we need this data. And it's really difficult to get this because go talk to any storage vendor, right? We talked about the IOPS thing again. They're going to tell you how many IOPS their box can push. But if you peel back the layers just a little bit, what you're going to find is they're telling you how many IOPS that array can deliver doing 4K 100% read blocks, right? These little itty bitty guys that everything is optimized for. Go flip that to a primarily write workload for a few minutes with 128K block and see how many IOPS that can deliver. It's a very different story, and that's, again, sort of the silent killer behind the IOPS question. So I didn't want to spend too much time. This isn't a session on large blocks, but if what I'm talking about here it either isn't ringing true or it's just an area you're not real familiar with, I highly encourage you to go out and take a look at this blog post. I'm happy to send it to anybody after the session. VM Pete is one of my colleagues, absolutely brilliant, came from the customer side of the house, really, really good VMware admin. And he wrote this this primer on block sizes, again, very non-product specific, but it's a very good educational tool on the relevance of blocks and how, frankly, you can deal with them. Okay, so we got it. We talked about IOPS a little bit. We talked about these block sizes and the random nature of the I/O. So back to the question: how many IOPS? Almost there, I swear. We will get to the answer. So before we get to that, we have to think about. You remember I was talking about this timing, right? So we send a request to the disk, but we've got to get something back. What we're really referring to there is now latency. So how long does it take me to get a request to disk and then get something back, an acknowledgement back, so I can do something else? Because, by the way, a Windows operating system won't move on to the next operation until it gets a response back from the one it previously sent. And so what you're seeing here along this purple line is the Datastore latency. And I'd be willing to bet, and anybody here is happy to, again, please feel free to challenge me on it. I could go into anybody's environment that has a traditional vSphere environment, right? Multi-host cluster with some sort of shared storage on the back end, and your latency pattern would look very much like that. The numbers up the side may vary a little bit. I've seen anywhere between 0 and 10 milliseconds to 0 and 812 milliseconds, my worst POC so far. But the point is, whatever the range is, this dynamic nature, this spiky nature, right, when things are congested and when things aren't so much, is just the side effect of that funnel that we create back to shared storage. What we want to see is storage latency that our virtual machines are getting that is nice and low and very consistent, regardless of what's happening back on the array. That's how we get better performance. That's how we get immediate response times that make our disk IOs move more quickly, that frees up our CPU cycles, that overall makes our virtual machines perform faster. So, just as a quick side note, a little bit about what we do and how we're able to accomplish such a delta here, right, between what's happening at the data store level and what's happening at the VMs, just so folks understand what you're seeing here. Basically, what we do with our acceleration technology is decouple the storage performance component from the storage capacity component. By moving the I/O requests up into the compute layer, right? And it makes sense. What does virtualization do for us? Well, it allows us to scale our compute and memory requirements out as far as we want, right? In a very scalable fashion. But storage, we're always creating that funnel. But what we want to do is allow, every time we add another compute node, we want to add more storage performance to that. So as we scale this out, things continue to perform better and better, not creating more and more of a bottleneck through the shared storage network. So when you look at this slide, what you're really seeing is, even though the data is taking a while to get back to the data store at some of these points, the virtual machines are never feeling any of that, because the virtual machines are actually getting their responses from that host side and essentially bypassing all of this, the storage area network, that big chasm of unknown, and the back-end array itself. Okay, so anything else? Did I cover it all? We talked about block sizes, we talked about latency. Forgot, there's one more topic. So here we've got read-write ratios. And guys, this is another one that was very eye-opening to me when I really started digging in and understanding the dynamic nature of a desktop workload. When you stand up an application server or a web server, it has a very predictable workload, and it pretty much does what it does all the time. 24/7, 365, we can have a pretty good idea of what that's going to do. I have absolutely no idea what any of you would do if I put you in front of a computer for a day. Well, maybe some of you guys, but the point is that our end users are very, very dynamic, and desktop workloads are very different than server workloads. So just as to give you a feel for some averages, right? During a boot storm, we see almost roughly, and again, these numbers are just ballparks to give you a feel for what we observe generally, roughly 90% read I/O during a boot storm, 10% write I/O. VMware released a technology, content-based read cache, that was later adopted for View to help specifically with boot storms, right? It's essentially letting you use a little bit of memory as a read cache. And man, it does a great job of helping take some of the pain out of a boot storm. But what happens as soon as virtual machines are done booting? People need to log into them. And so think in a classroom when you've got 50 students that just booted up a bunch of VMs and they're all logging in at the same time. Well, now we create a login storm. The login storm almost flips that number. 10% reads, 90% writes as the profiles are getting set up and we're accessing things. And so whether we're doing AV storms, patches, updates, all these different things, they have very different patterns. All of this separate from what the end users are just going to do, like YouTube and all the other things that they do. And so we can very quickly, as you can see, in just a couple of minutes, go from extremely heavy, here I've got extremely heavy writes to roughly a 50-50 split, just in a couple of minutes across my cluster. So understanding the read-write ratios and the associated block sizes to those read-writes, again, is critically important in making good design decisions about your storage. Okay, so I'm not. Unfortunately, I've been fooling you guys the whole session. And I have to apologize, throw my water on myself, because the reality is that I can't answer the question. The storage industry has been trying to answer the IOPS question for many, many years, and unfortunately there is no magic number. I hope as I've shown you some of these things here today, you start to get the understanding that trying to simply put a number on IOPS and purchase an array that can deliver that number of IOPS is not really the right way to buy storage for VDI. It's not really the right way to buy storage for any project, but especially something as critical and as difficult to make successful as a VDI deployment. So again, just to kind of give a quick recap, we need to understand the correlation between what's happening at our latency and our throughput, our workloads, our IOPS, all at a given time. Understanding the read-write ratios and the block sizes, critically important concepts because, again, Windows doesn't just sit and write 48K block all the time. It would be great if it did. Unfortunately, the workloads that we are forced to put on it simply don't. So just to give you a feel for it, there is light at the end of the tunnel. This is one of the deployments I had an opportunity to work with. As you can see, we're actually generating over 106,000 IOPS during a boot storm of We've got over 1,500 virtual desktops in this cluster. And you can see all of those during that boot storm of 106,000 IOPS we're experiencing less than half a millisecond on aggregate across all of those virtual machines. Folks, for those that aren't familiar, half a millisecond is really fast, especially at that level of performance, right? A typical SAN, right? In a good performing environment, folks, the storage folks, VMware will tell you less than 10 milliseconds is pretty good. I go into customers every day that tell me that they get under 10 milliseconds, and maybe 70% of the time that's true, but inevitably that latency spike that I was talking about, that pattern, is there, and there are always spikes of 30, 40, 50 milliseconds, and that congestion is having a negative impact on how fast SQL jobs are getting done, on how fast virtual machines can log in, etc., and folks don't even realize it. So this is a slide from one of our co-founder, Satyam Bugatti's presentations for Virtual Field Day 5. I'm going to talk a little bit more about Satyam in just a moment. But what I wanted to call out here is we used an industry standard benchmark tool, Login VSI, to basically figure out what we could do. How many desktops would this thing give us, right? So again, we can't answer the IOPS question. So given a set of hardware, right, couple of hosts, a fixed amount of memory, etc., so much disk on the back end, and there's more details on this particular build if anybody wants it. But basically it's, well, let's run Login VSI, which for those that aren't familiar, it'll boot a bunch of virtual machines. It will actually simulate real-world workloads where an end user launches applications, types things, closes things, all that. And then basically what will happen is once the user experience degrades enough, right, to a point that their benchmark says, hey, things aren't responding quickly enough, you failed, then it cuts the test. And so what happened was, without putting us in the mix here, we were able to generate 181 workloads before Login VSI said, you're done. So what we did was go in and say, well, let's just steal a little bit of memory. We don't even have to add memory to the hosts, because the reality is the CPU, the memory, none of it's being fully utilized because the disk can't keep up. So we simply stole a little bit of RAM, about a gig per desktop, and we simply gave that to the acceleration tier that Pernix data provides. And we were able to, just by stealing a little bit of memory from each of those Windows desktops, we were able to nearly double that number. With the same threshold, you can see we ran all the way up to 328 desktops on the exact same hardware. Imagine what that would do for your total cost of ownership. For, well, I don't want to speak for Sean on the back, but for a very, very small amount of software dollar spend, to be able to nearly double your VDI deployment on a given set of hardware, there's really nothing else on the market that can do that sort of thing. So I mentioned Satyam, and again, this is one of the slides I stole from marketing, and I won't go through all this, I promise, but I do want to at least call Satyam out because, frankly, he's a lot of the reason that I'm here, and I think a lot of the folks in our organization. So Satyam was one of the original engineers at VMware, and his original claim to fame was he patented VMFS. So I think everybody in the room is probably pretty familiar with VMFS, but for those that might not be, it is the technology that allows vSphere, scale-out compute, to talk to shared storage. It's what enabled things like vMotion, DRS, HA, etc. And so Satyam was with VMware for about 10 years, drove a tremendous amount of innovations, patented things like vVols, VAI. He's got, I think, close to 50 patents to his name today. The man's brilliant, and it's really his insight and capability that has allowed us to do what we do here. There are a number of technology companies out there, including VMware, with things like VFRC, that have tried to do this, and have either failed or have done pieces of it, but nobody's been able to provide the level of performance with the level of invisibility that we provide. Everything that we talk about, oops. I dropped that other slide, Sean, sorry. So everything that we talk about here, guys, is completely invisible to your back-end storage. Everything we talk about is completely invisible to your virtual machines. You don't need to do so much as a reboot to your VMs to take advantage of this type of technology. It's truly a hypervisor level extension that essentially enables us to provide that scale-out performance concept for storage performance, just like VMware's been doing for the compute layer for many years. So with that, I want to pause and just see if there are any questions on any of the concepts that we talked about here today, and see if there's anything else that you guys would like to see.
Josh, can you address in the scenario of, let's talk about just existing technologies for people today. So in your past, in the way that some of the installs have stalled out, if you will, now hyperconverged exists. What are some of the benefits that somebody might see out of hyperconverged that would have prevented a stall in your mind, right? I mean, it's just one man's opinion, right?
So it's a great point, Sean. So when we were talking about putting this session together, the idea behind the stalled VDI deployments came from the fact that I did a lot of workshops, and the workshops were targeted at customers that had said, they'd come to VMware and said, we'd like to buy into View, we're going to do 2,000 seats over the next 18 months or whatever. And they get their pilot done with 50 desktops and things look really good. They deploy their first 100 desktops and things looked really good. They'd hit that 200th desktop and things started falling apart. By the time they got to 300, performance was so bad nobody wanted to use it anymore. And so we would go in with a workshop and start trying to identify all the potential bottlenecks and things that might be there to get it back on track. And 99% of the time it came down to storage performance. And so the idea was, well, how do you fix that? And for a long time, the only option we had was to go basically tell them, you know what, your storage array simply isn't good enough. How many folks are doing VDI in the room today? Have a production implementation? Okay, so of those folks, if you don't mind my asking, keep your hand up if you are using the same shared storage for your servers as you are your desktops. Who bought dedicated storage just for the desktops? One guy, okay. So that was a very common recommendation. If we're having trouble here, simply isolate, get a dedicated vCenter, get a dedicated storage appliance for this. Who runs server and desktop workloads on the same cluster? Just one? No.
No, they're actually different clusters. Same storage.
Same storage, but different compute cluster, right? That's much more common. So as you can see, the general recommendation over time, as people have fought with the challenges, is isolate VDI, right? Create a separate cluster, create a separate vCenter, create a separate storage unit, and by isolating everything, things will get better, right? We'll quit crushing the I/O and messing with your servers. VDI will get better, and it does. It helps, obviously. There's less contention there, but now that's somewhat problematic. And going back to Sean's point, I think hyperconverge is sort of the next natural leap there. Well, if I'm going to have to create this separate thing and manage it as a separate entity anyway, I guess, if I just had an appliance, right, for my VDI project, that would be great. And it's not a bad point, right? If I've got to manage two environments anyway, I'd much rather have one that's really easy and all that. But what I found is that most people, when you get in and really start asking them, are you happy with this separate? Are you happy managing the appliance and things there and keeping your server infrastructure this way? Most people don't like it very much. Most folks don't want to have a storage array for this project or a separate compute cluster for that project, etc. It's more management, it's more overhead, it's vendor lock-in because, well, that appliance is really only good for that workload. It's very problematic, it's very challenging. And so we, as we went down the path, and frankly, as I looked at many of those technology vendors to help me help my customers on the VMware side, I was really hesitant to go the hyper-converged route, and I really kind of stand behind that today. I think things like vSAN and Nutanix and such have, if you're in the mindset that you want to have that separate dedicated environment and you're okay managing that, yeah, then maybe it makes sense. That's no problem. But the stance that we take is we think most customers that have been doing VMware for the last 15, 20 years have a pretty good idea on best of breed, on what they're comfortable managing, and they've gone through and they've built out beautiful compute clusters, really good networks, really excellent storage, and to try and disrupt that and dictate your hardware build isn't what most people want. And so by integrating at the hypervisor level, that's really the approach that we take. We don't care what your infrastructure looks like, right? What host you're using, what storage you're using, what network you're using. It's all invisible. We're invisible to all of it, right? Because we're operating at the hypervisor level. So I only got one question, and it's from the guy that I got to work with every day. Anything else? Yes, sir?
What's involved with setting it up?
What's involved with setting the technology up? Great question. Thank you. So we are 100% software. As I mentioned, we install directly into the hypervisor. Our secret sauce is about 6 megs of code. As you can imagine, ESXi is a pretty tight code set, and we're just a little piece in that kernel. So what's involved is about an hour at a time. We put a host into maintenance mode. We run a single command line. You can use VUM, you can use auto deploy, whatever you want, or a simple SSH command line. Plug the code in, pull the host out of maintenance mode, and you're up and running, right? So we can do this in a rolling fashion across just a couple of nodes or an entire cluster without taking any sort of outage. And what we'll do initially is start providing you analytics. Every screenshot that I showed you, that I was talking through, you know, that values, the read-write ratios, all those things, those are all came from my customer sites. As I do proof of concepts and help people understand their environments and their workloads, we put that data in your hands. And so a POC day one will provide you that kind of data about your existing environment. Day two is if we start to identify bottlenecks and potential room for improvement, we'll actually make recommendations in the tool itself that will show you where you can make those recommendations. So rather than blindly going through and throwing hardware at a problem, maybe it'll fix it, maybe it won't, we can go through and on a VM by VM basis figure out how to optimize this. Give you guys one really quick example. I worked with a customer, a long-time customer of mine. He's been using Vue since the very early days. He was one of the first adopters of hardware-accelerated 3D graphics. He runs an architectural engineering firm. And so one of the challenges he was having was he has a next-gen array, and paid a pretty penny for it, right? Fusion IO card tier of flash in there. And it simply wasn't getting the performance that he wanted. The 3D side of it was great, but when he'd open these massive architectural engineering models, it would take sometimes as much as 4 minutes for a model to open before his end users could start working on it. And he couldn't figure out why. The array was telling him, hey, everything's fine, this all looks good. VMs seem to be running fine, couldn't figure out what was going on. We put the tool in, figured out very, very quickly that he was having huge latency on the storage area network. We accelerated that, and in the first 5 minutes, his model went down from a 4-minute load time to about 28 seconds. It was done, right? I mean, that closed the deal for him. So this is very, very real. It's very, very easy to try. In fact, you know, Sean and I absolutely love to do proof of concepts, right? There's no better thrill than going in and actually giving a customer real data that they can use and saying, there are no strings attached. You have this data for 30 days. If you like it, call us. If you don't, you get the data and we walk away, right? So encourage you guys to take advantage of that. How much time do we have? We're done. We're done. We're done. Excellent. Thank you guys very much.